Okay. So now we move away from your correlation analysis as well as your normal data analysis, and we get to the real stuff, the regression analysis part. Now this is only a simple regression. Now simple regression typically refers to a regression analysis where you only have one dependent variable and one explanatory variable. So you've got one variable that explains the other. Now there's always only one dependent variable. Okay, there's always only one dependent variable, but you can, in a multiple regression case, have an endless amount of explanatory variables or independent variables. But in this case, we are only looking at the simple variable case for now. So consider the following. Consider that your Standard & Poor index influences your Ford share price. So what would you say your dependent variable is and what's your independent variable? We know that the S&P influences the Ford share price, so we can say that our Ford share price is our dependent variable and our S&P index is our explanatory or independent variable. Okay, very important to remember this, okay, when you run your regression analysis, because remember the way of direction here is important. Now it asks you to to express or say what your expected relationship is. What's the expected relationship between S&P and the Ford share price? We expect that as the S&P go up, the Ford share price goes up as well. So as the index move up, we expect that the Ford share price or the individual stock will move together with our S&P. So we expect a positive relationship. Now, this is just for the purposes of your assignment. These steps are important. So follow these steps. Follow these steps when you ultimately run your assignment. Okay, this is a good guideline of how to actually do your assignment. So you have to, for example, in your assignment say whatever your variables are, what you expect the variables and the relationships to be. Now it asks us to run a regression analysis of X and Y and report the regression line. So we go back, and to run this there's a few steps. First you need to go to quick. Okay. Then you need to go to estimate equation, and in this section you are going to estimate your equation. Okay. So here the first thing that we have to specify is our dependent variable. If you think about in your slides, the equation, it is y, which is our dependent variable, is equal to our intercept plus our explanatory variable plus our residual. So we start with y. We start with our dependent variable. We've identified that to be Ford. C is our constant. We always have C there. We always have our coefficient there. So C is our constant, followed by our independent or explanatory variable, which in this case is our Standard & Poor. Okay, so this is our simple regression case. We've got our Ford, which is our dependent variable, C for our intercept, and your S and P as our explanatory. And this you do for anything. If you want to see what the effect of GDP is on the MTN share price, MTN will come in play here as our dependent variable. We'll always have our coefficient, and we'll have our GDP as our explanatory variable. Okay, we can run this, and then we end up with this, where we've got our dependent variable as Ford, tells us the method, least squared method, and this is then our output. Now to report our regression line, we can simply go to view, estimation output, view representation, and this is our regression line. Don't get confused by the line bit. The regression line refers to what does our scenario look in our as specified by our equation. So remember, Ford, our y, think of the generic equation y is equal to, here we've got Ford is equal to our intercept. Now where do we get our intercept? Where do we see our intercept? C is our intercept, right? C is our coefficient, or C is our intercept, so you look at the coefficient of C to get the intercept. Okay, so the coefficient of C, remember C being our constant, that is our intercept. And then to get our beta, this is our beta. Our coefficient of our explanatory variable is our beta. Now, but if you go to view representation, it gives you this already. It gives you the intercept, which you can derive as just shown. Plus, we've got a positive relationship, our slope, which you could have seen there as well, times our S&P. What you need to add to this line, though, which is not added here. So this, you're going to write down in your assignment. You are going to write down this regression line. Okay. What you need to add to this is you need to add the residual, and this is the residual, the standard error. So you're going to, it's positive, so to the line that I've just shown you, you're going to say plus 0.01353 as your residual. Hope this makes sense. So this bit will be added to here, so you'll say plus that bit, and that is then your full regression line. That's your full regression line. Okay, hope that makes sense. If it doesn't, watch the video over and over again. So, does the sign of the parameter coefficient or confirms the expected relationship? So we go back. Like I said, the coefficient of our S&P is our not our intercept, it's our beta, it's our slope. So if you don't know what a slope is, go back to the slides. What is the slope? It's the effect or the level to which the S&P, a change in the S&P affects our Ford. A change in the independent affects our dependent. So it's positive firstly, right? It's not negative, so it's positive. It's positive. So does this confirm our expectation? Yes, it does. We expected a positive relationship between Ford and S&P. We expected to see that as Ford go, or as S&P goes up, Ford go up with it. So yes, it confirms our expectation. Now we interpret the beta coefficient. So in the slide set, I've interpreted the beta coefficient already, but I'm going to do it again. So this is our beta coefficient. This is our slope. So we're working with dollars in this case, right? Because the S&P is quoted in dollars and the Ford is quoted in dollars. So our unit of measure becomes the Ford. The dollars. Okay. And so how we interpret this is as follows. A $1 or a 1 unit increase in our S&P index. A $1 increase in our S&P index will result in a $0.03459 increase in our Ford share price. I'll repeat that. A $1 increase in our S&P, our independent variable, a $1 increase therein, will result in a $0.003459 increase in our Ford share price. And that's how you interpret it. It's as easy as that. So you can see that it's a fairly weak effect, right? Takes the S&P. So, and just by the way, it's always the interpretation is always a 1 unit increase. If it's dollars, it's a $1 increase. If it's rands, it's a 1 rand increase when it comes to our explanatory variable. Important to remember this. It's always a $1 increase in our explanatory variable results in our beta. If this was negative, it would have been a $1 increase in our S&P resulted in a decline of $0.003459 dollars or units in our fall share price if it were negative. Compare the actual versus fitted values. This is just for interest sake to see how good or bad our estimations were. So you go within your equation, so you don't go out, within your equation you go to view, actual versus fitted, go to the graph so that you can visually analyze it, and here you see the red line is what we estimated it with our regression analysis. This is what we've estimated it to be, and this is what it actually was. Okay, so you can see there where, and this is our residual, just so by the way, the blue is our residual, so you can see the places where our actual deviates far from our is estimated, our residual grows, our mistake grows. There where it's on the dot, our estimated is actually the same as what the actual was, our residual is close to zero, our mistake is close to zero. So this just shows you how our residual is formed based on actual versus fitted. Do we see outliers? Yes. Look at, there's an outlier, there's an outlier, there's outliers. So yes, we've got residuals that does that there are outliers in our residuals. In other words, we do get spikes in our mistakes over in our error over time. This will typically violate our assumptions, but we're not going to test our assumptions now. We'll do it when we do the multiple regression analysis. This is just to get an idea and a feel for it. Okay, you've plotted the residuals already. That was your residuals. Now determine whether beta is equal to 0 or not. Okay, in other words, determine, and if you do not know how to do your if you're not sure about hypothesis testing, go back to the slides. There's steps, there's 4 steps that you need to follow. I'm just going to explain how to use beta, but you need to follow those 4 steps. So importantly, at a 95% significant level, go back to the slides if you don't know what I'm talking about, at a 95% significant level, we can reject our null hypothesis. Now this means, what does a beta 0 mean? Remember, it means that we've got a statistically insignificant, a not significant variable. Now in order to reject this null hypothesis, our p-value needs to be lower than 0.05 to reject our null hypothesis at a 95% confidence level. Okay, if you don't understand, go back to the slides. And so we go back to our this is still within our equation. We go to view, go back to estimation outputs. This gets us back to our initial page, and our p-value is our prob of our S&P. Remember, for us to reject the null hypothesis of beta being 0, thus to reject that our S&P is not significant or does not have a statistically significant effect on Ford, okay, our p-value needs to be lower than 0.05. Now in this case, it is right. It's 0.0117. So it's lower than 0.05. So what we can say is, we can draw a conclusion to say that our p-value is lower than 0.05. Therefore, at a 95% confidence level, we can reject the null hypothesis of insignificance and accept the alternative hypothesis of significance. And thus, our S&P does have a statistically significant impact on our Ford share price. Okay, happy with that? Hope you are. This is how you interpret your beta coefficient. Your p-value. This is your beta coefficient, this is your p-value, and this is your intercept. We don't care about the p-value of our intercept. We only care about the p-value of our explanatory variable. Lastly, report and interpret R squared. Okay, remember R squared is the square of our correlation coefficient. EViews provides it for us right there. Our R squared in this case is 0.046534. How do we interpret this? Listen carefully, and you can listen to me again, luckily, because it's a video. It means that 4.6534% 4.6534% of a variance in our Ford share price is explained by a variance in the Standard & Poor index. A 4.6534% of the volatility. Sorry, I said increase. It's not increase. It's not increase. It's volatility. So 4.6536% of the volatility in our Ford share price can be explained by the volatility in the Standard & Poor index. I'm going to say that one more time. So a 4.6534% volatility. So 4.653% of the volatility in our Ford share price can be explained by the volatility in the S&P. Hope that makes sense. Very important. There's one of these questions in the assignment. So you need to understand this and how to interpret this. So the assignment, just quickly. Let's go to. Okay. So identify an academic paper or article that uses a regression analysis as a method to answer the corresponding research question. Okay, so whatever those researchers selected their research question to be. Your assignment will be based on this article, and you will have to reference this article throughout your assignment. Okay, referencing importance, proper referencing style. You have to replicate the identified articles in terms of the variables used and the methodology used. Now, articles will never use a simple regression analysis. It's too simplistic. So, but for the purposes of your assignment, you only need to have a simple regression analysis. So you only have to get the idea of other papers. So if a paper's main goal was to identify the effect of the exchange rate on the stock market, you'll typically have the exchange rate as a dependent or as an explanatory variable, and the exchange rate as a dependent variable. Okay, hope that makes sense. So that might have been done in the US, but in South Africa you do a similar thing, but you just take the South African rand with our local index. So forget about all the other variables that they've used in the article. You are only going to specifically, obviously, look at South Africa or two variables in the South African case, but it needs to replicate to a certain extent what they've done. And they might have ran a panel or whatever. You're not going to run a panel. You're just going to run a simple regression. So even if the article used a multiple regression, you only need to have one dependent and one independent variable, because it's only a simple regression. An example would be if you get a study that determines the effect of a change in the oil price on the stock price of an American oil company. You can then use the idea and implement a simple regression analysis to determine the effect of a change in the oil price on the Sasol share price. You may not use this example. Once again, proper referencing. Then give me a brief 500 to 1,000 word introduction and background. Remember to reference background. What's the idea? So I'm doing the effect of oil on the Sasol share price, typically because oil, Sasol is an oil producing company, and increase should, positively have a positive effect on the Sasol share price. And you can reference one or two papers that gives you a similar finding, and so on and so forth. So you give a bit of a background of your study, what you are doing. Okay, then describe the data in terms of what they are, the time span of the series, the data frequency. This must relate back to your article. So if they've used monthly data, you use monthly data. If they use daily, you use daily. and you have to tell me how far it dates back. Now, it doesn't need to exactly be the same as your article. Okay, but if it's from 2000 to 2019, that's your time span. Calculate and report the mean, standard deviation, so on and so forth. You should know how to do this. Plot a XY diagram between the two series and report what you see and expect in terms of the relationship of these variables. Go back to the videos if you don't know how to do this. Conduct a correlation analysis, conduct a regression analysis, report and report the beta coefficients. You also have to interpret the beta coefficients and link your findings to the findings of others. All your papers, so if they found a positive relationship between oil and a oil producing company, you have to say, does your findings confirm those findings, or is it the same, is it different, and so on and so forth. Follow hypothesis procedure to identify the significance, and then use the R-squared to see how good your model fits. Okay, interpret it according to my interpretation on the videos. Hope this was helpful, hope you understand. Be free to email me if you have any questions.